Okay, so there's a really interesting thing that happens. If you combine an aqueous solution of lead to nitrate and another aqueous solution of potassium iodide, these two colorless solutions, when you combine them together, they actually form a yellow solid. So why is it that when we combine ions together, we actually sometimes get a solid to form? Well, it turns out that that when certain ions like lead and iodide, when they're together, we get a solid because certain compounds are insoluble. So if you combine the right ions together, you'll get an ionic solid. So as an example, generally halides like chloride, bromide, and iodide are soluble. They're soluble. That is, they can dissolve in solution of water. However, an exception to this is when you have lead present. So if you have lead and iodide present, you'll get lead iodide solid to precipitate out of solution, to fall out of solution. And so, gosh, there are a lot of special rules here. There's a lot of ions to be aware of. And so you do need to know these, but I think probably 80% of all of the questions that you get on precipitation reactions are going to involve these 5 common ones. Nitrate. This is always soluble. Anything with nitrate is soluble. Another exception, or another special one, ammonia. Sorry, actually ammonium. This is always soluble. Lithium ion, sodium ion, potassium ion. These all, if they're attached to anything, they're always soluble still. And so if you know that, that's going to help you solve like 80% of precipitation reactions. So those are some really key ones to know. All right, so when we have precipitation reactions like this, we have to write out what actually occurs in a kind of a more convenient and accessible manner for ourselves and then for anyone reading it as well. So before we do that, though, I do want to mention, what actually occurred when we combined those two solutions. So we combined a solution of lead iodide together. Now, that solution, it had separated ions because they were solvated in water, hydrated in water. And we also combined that with a solution of lead nitrate. So again, separate ions. But when that lead is near the iodide, they will sometimes come together, and doing so, they're actually going to be more stable together than solvated in solution. And so they'll fall out of solution and form an ionic solid, lead iodide. And you see how it's kind of a well-ordered structure, so it falls to the bottom. Now, we can actually generally just say, hey, potassium wasn't really changing here. Nitrate wasn't changing here. You see, they're both still solvated in solution. The only things that really were changing were the lead and the iodide. So really, we can just say the lead and the iodide, they combine together to form solid. So this is kind of a nice, quicker way of writing out anything that occurred. This is our net ionic equation. And do you see how much less writing is involved and how quickly you can communicate to a reader what actually occurred? So let's go ahead and practice writing the net ionic equation. There's a couple rules or steps that you want to follow. So step number 1, you want to just write the balanced molecular equation. So let's go ahead and do that here. We combine lead nitrate solution with potassium iodide solution. So if you need to predict, because you will need to predict reactions, if you need to predict a reaction like this, I like to break it up into parts. So generally, a lot of what happens when we have these double displacement or metathesis reactions is that the cations kind of replace each other. They switch places. So pretty soon what's going to happen is you're going to have your potassium ion, K+, hanging around with those nitrate ions, NO3-. And you're going to have, let's see, that lead is going to hang around with that iodide. So what's the charge of this lead here? Well, if you need to figure it out, you can figure, hey, each of these nitrates, you've memorized this, has a charge of -1. If we have 2 nitrates, then we have an overall charge of -2 in the anion side. And because we have all the charge balanced out, there's no overall charge here, that there must be a +2 overall charge from all the cations, and there's only one cation. So that +2 must come from that one lead. That lead is a +2. Okay, so we've got a lead +2 charge, and we've got nitrate, actually iodides as well, I-. Halide, memorize it's -1. So we combine these ions together, and so they combine in ratios so that the charges balance out. Just in this case, 1 potassium per nitrate. And that's an aqueous compound. How do we know that? We go to our chart, or we know anything with potassium or nitrate is always soluble. And then what's the other compound we get? Lead 2 iodide. So there's 2 iodides because we need 2 minus charges to balance out the +2 of the lead. And that is going to be solid. We know that from our chart. Now we need to balance our equations. So let's see. I don't know. Let's see. We have 2 iodides here. We have only 1 iodide here. Put a 2 there. Now we have 2 potassiums. We have only 1 potassium. Put a 2 there. 2 nitrates, 2 nitrates. 1 lead, 1 lead. We're balanced. Step 1, check. Now we want to write the complete ionic equation. Now it's very important here that in the complete ionic equation you write anything with strong electrolytes, anything that's aqueous and is also a strong electrolyte, like a strong acid or base. We break that up into ions. So let's take our molecular equation, and let's write that as the complete ionic equation. So lead nitrate, that's aqueous, and it's ionic compound, so it's strong electrolyte. So we'll write it as Pb2+, and 2 separate nitrates, 2 NO3 minuses. And then there's 2 potassium ions and 2 iodide ions. Those are our reactants, and now let's write the products. We have 2 potassiums, and we have 2 nitrates, and we have 1 lead iodide solid. Why did I write my lead iodide solid together and not as separate ions? It's because it's solid. So it's not acting as a strong electrolyte, and it's not soluble. It's solid, not aqueous. Okay. So now we've written the complete ionic equation by writing out all the aqueous strong electrolytes as separate ions. And now we need to do step 3. We need to cross out spectator ions. Let's see, so what is a spectator? What is only watching, like at a baseball game? There's 2 nitrates on both sides here. Nitrate's not changing. Let's see, potassium is not changing. Lead certainly is. It went from being separate ions, aqueous, into being part of a solid. That did change, and so did iodide. So now we need to, in the rest of step 3, write the net ionic equation. So what's left over after we've crossed out the spectator ions? So lead is still there, Pb2+, and 2 iodides, and then that gives us lead iodide solid. You don't need to write these guys are aqueous. It's assumed if they're separate ions. Okay. Number 3 done. Now we check for balancing of elements and charge. We have 1 lead here. We have 1 lead here. We have 2 iodides here. We have 2 iodides here. The overall charge on this side is 0, and the overall charge here is 2+ and 2-, so it's 0 as well. Great. We have completed this. All right. Thanks for watching, guys. See you tomorrow.